So this is a solution to the two-button exercise, but this time this solution doesn't use the delay code in there, so that we're able to have a more fine control over the buttons. So the issue with the delay code when we were doing the automatic mode is we turn on the light and we delay it, and then we turn on the other light and the other one off and we delay it, is that when the other button is being pressed, it's not being detected by our code because it's delays in the middle of our code. And the button detection is a certain part in our code. So this is a solution where I call it the no delays. So it's a two-button exercise, no delays. And again, just a reminder, what the exercise does is we have two lights. In this case, I have a green light and a red light. One button does what I call manual mode. By pressing that button, it alternates which light turns on and off. So it's what I call toggle. And then the other button goes into automated mode. And when automated mode, the lights act like a siren, so it goes back and forth slowly for about 5 times, and then going back and forth quickly for 10 times or 15 times, all automated. And that cycle repeats itself until the toggle button is pressed, and then the automated mode stops, and then the lights will go back and forth depending on whenever the toggle button is being hit. So the code itself hasn't changed a lot. So the variables at the top should be the same as what I had before in the two-button exercise solution. My green light is hooked up to the pin 8, and my red light is hooked up to pin 9. My toggle button, once it's to manually get the lights to go back and forth, is hooked up to pin number 4, and the siren light or the automated button is hooked up to pin 5. So at the top, this is what I've sort of done to sort of have our code not delay. So essentially what we need to introduce into our code is a timer. So instead of asking the code itself to wait half a second or whatever it is, 500 or 1,000, we're just going to have to time it every single time, and the timer increments by 1 every time it goes through the loop. And so once the timer hits a certain value, we know that a certain amount of time has passed. So one of the things that roughly is that the loop itself, this is how fast our Arduino is going, it runs about 100,000 times per second. I haven't done a scientific study or measure about this, but it's approximate 100,000 times per second. And that's if we don't do the serial monitor. Sometimes if we want to turn on the serial monitor and do the print to the serial monitor for debugging purposes, this actually slows down our code by 100 times factor. So this is why I created this variable multiplier, 100. And basically, if we don't have the serial monitor on, if we're not printing to it, we want to leave it as 100. But if we turn that on, we're going to set that back to 1. So really what we're going to say is a millisecond is really 1/1000th of a second is really 100. So in other words, it's going to take 1/1000th of a second, our code's going to run 100 times. So we define this variable. Millisecond is really 100. And then now we sort of change our delay times. Now we're looking for a specific value. So it's not just 500, but we're looking for 500 milliseconds. And for the fast delay time, instead of 0.2 seconds, we're looking for 200 milliseconds. So we're going to take 200 multiplied by the millisecond variable. So in this case, it'll be 50,000 and 20,000 respectively. And that's what we're going to count to. So that's how we know that the light is going to be on for a certain time, if it's going to count to 50,000 or 20,000. I had to multiply the number of times slow and fast by 2, because this variable no longer keeps track of going back and forth, but just going from the light once. So in this case, because we want to go back for 5 times, well, that means each of the lights is going to turn on 5 times, but since we have both 2 lights, it's going to be looking at 10 times. So that's how many times we want to count through the number of slow times, because now we're doing each light individually. I've also introduced another variable called timer. So this is the variable that's going to go through the timing and counting. One important thing to note for these variables is that I create them as long. So the other variables are int, which is fine. One of the things that we recognize in the Arduino code, it's a little bit like C in terms of int. We have to define a type, but in this case, int only is I believe, a 2-byte variable. So this only keeps tracks of values up to about 65,000 thereabouts for unsigned, but because we have to worry about positive negative, it only keeps track of approximately 32,000. So long is really big. It gives us a 4-byte value, and this can store up to values up to approximately 2 point something billion, which is more than enough to handle what we need to do for the counter. But unfortunately, int is not long enough, so that's why I had to create these variables as long. So these other variables have stayed the same as my other solution. So I still have states for my green light and red light. So by default, we're going to have them as off. I still want to count how many times it's blinking through the counter. How many times it's blinking in the automated mode. So I need a counter for that as well. And we have a button mode and our LED delay time. In other words, how long we're going to wait for the light to go through. But in this case, we're not going to delay by this amount, but we're going to wait to see if our counter hits that certain value. Our setup really hasn't changed. The only thing that's added to our setter is that we're going to set our timer. In other words, we're going to start counting at 0. So we're going to start the timer there. So that's the only addition that we have in the setup. Inside the loop, well, not much has changed. Well, nothing has changed for the toggle button, because the toggle button should be working as it was before. But I'm just going to show the code here. So this is where the loop starts, like with the toggle button. And here we're going to check if the toggle button is pressed. We're going to store it in the button pressed variable again. And then we're going to check if that has been pressed. So going through that code, if the toggle button is pressed, it's going to execute this code. So let me see if I can fit that on one screen, almost. So here's the if condition in there. So the first thing that we did again was, if it wasn't in toggle mode, we're going to switch into toggle mode. So that's what this line is here for. We're going to say the button mode's in toggle. And then we're going to set the lights to a certain state so that once we turn the lights on and off, that will happen. So again, this code hasn't changed. So again, this is coming down to the bottom of our toggle code. And basically, if the green light was on, but now we're going to turn it off and turn the red light on. Otherwise, we're going to assume that the red light was on. So now we're going to turn on green light, and the red light state will be off. And this is where we do a digital write. In other words, turn the respective lights on or off. And then here, we still need this delay for the button, because again, our button's kind of finicky, so we just want to sort of slow it down or have a little pause there to give it a chance for the person to release it so that it doesn't stick and that it toggles too fast on us. So here's the code for the automated part. So here's the code for the siren. So this part itself hasn't changed, so we still have this condition that if the siren button is pressed and we're not already in siren mode, so the button mode, now we're going to switch it to siren. The blink counter is set to 0, so we're going to start counting how many times we're going to blink back and forth. We're going to reset that to 0. And the LED time, we're going to start with the slow delay time, so that's the delay time that we're looking for. And this is the one addition that we have now, is that now that we've switched into siren modes, we want to reset our timer. We're going to start our timer at 0. In here, what I've done is that I think before I might have had to set the green light on and off, green light on and red light off to start. I decided to change this program around a little bit, saying that when we start the siren mode, depending on where it was in manual mode, we're just going to keep that going. So for example, if the red light was on and the green light was off, that's where the siren mode is going to start. Otherwise, if the green light is on and the red light's off, we're just going to start the siren mode there. So we're not going to sort of have a default start state, but it's just going to continue where the manual lights are at. So that's why we just do a digital write for the green light and red light, whatever the state is on. And then again, we're going to have that delay on the button to give a chance for the user to sort of let go of it. Now in the code that if we're in siren mode, so this code has now changed. Because now what we're doing is that if the timer, now instead of looking for a delay, we're saying that if we're going to the timer, if the value of timer is the same as however long we want to delay for, that means that time is up. So whether it's 50,000 or 20,000, it's going to go check whatever that value is. So once it hits that, then we're going to say if the green light's on, we're going to turn it off and turn the red light on. Or otherwise, that means the green light is off, then we're going to turn the green light on and the red light's off. Because now we sort of hit that one end of the cycle for the light to be on, we're going to increment our blink counter. In other words, this is blinked so many times. And now that we're granularly controlling each light, this is why we had to double how long we're going to count for the blink counter up above. So now that once we sort of detected however long this light is on for, that's what the purpose of the timer was, now we're going to reset that to 0. So we're going to start the timer again in essence, and then we're going to turn the red light and green light on respectively. The rest of the code has not changed because basically now we're saying that when we're using the LED delay time is that if that was already a slow time, in other words, we're going back and forth in the slow times. Now we're saying that how many times it blinked back was the number of slow times we wanted. We're going to switch the delay time to the fast time, and we're going to reset our counting of the blinking. Otherwise, that means it must have been at the fast times. Then if we blinked the number of times we want for fast times, then we're going to switch the delay time to slow time, and we're going to set the counting of how often the light has blinked back to 0. So this code has not changed at all because it doesn't rely on the timer itself. It's sort of just checking what state we are in terms of are we in fast or slow, and then counting are we at the value for wherever it is that we want the blink amount for. So that part hasn't changed. So really the gist of the code that has changed is this one little if condition over here where we're actually looking at the timer. Oh, I think I forgot to mention this code here, which is really important, is that every time we're in here, every time the button is most in siren mode, we want our timer to go up by 1. So that's what the plus plus means, which is going to add 1 to the value of timer. So let's go from 0, 1, 2, 3, all the way to either 20,000 in this case or 50,000. And then once that happens, then we're going to switch the states of the lights. So that's the logic of the code there to sort of manage our own timer. So let's upload this code. And then there it goes. So let's see what it looks like. So this button over here, this is my toggle button. This button over here, this is my automated or my sirens button. So you see the green light is on. So the toggle button should still work as is. And now if I hit the sirens button, it goes off. So it's going back and forth slowly for about 5 times. And now we're going to go alternating fast again for about 15. And then it's going to go back to slow mode. So now this is the important part where now wherever the button is, wherever the light is green or red, when I hit the toggle button, it's going to stop exactly there. So it wasn't so much of an issue when it was going fast before because there was less of a delay in our code. But now when it's going slow, let's try this. So when it's in red, if I click on that toggle button, it notice it stopped right in red. In other words, in our code, because there's no delay, it's going to read that right away. So here I could toggle it. Okay, and so this is the other part where I kind of mentioned is that if I go back to siren modes, it's actually going to start on the red this time. So it's going to start on the red this time, and it doesn't start on the green right away, but it's going to remember that state where it was, and that's where we're going to start the sirens mode again. And this time I'm going to stop it on the green. So when it starts on the green, we're going slow again. I'll use the toggle button to stop it on the green, and right there, so it reads that read the button right away because we don't have a delay. So again, let's start the siren mode again. And here I could even stop it on the red, start the siren mode again, stop it on the green, start the siren mode again, stop it on the red. Because now it's going through, and because things aren't delayed anymore, it reads that toggle button right away wherever it might be in our sequence or in our cycle of the lights. Okay, so that's how we could do the 2-button solution without a delay. So we have a lot more granularity on um, uh, reading that button when it's pressed and doing the proper doing the proper code that we wanted to do, doing the proper functionality. So this is going to be really important for you to sort of enable the buttons in your traffic lights assignment, because again, that the traffic lights are going through that pattern, and no matter where it is in that pattern, we will want to detect if one of the buttons is pressed and then have the traffic lights react accordingly.